In this video, we're going to be checking out the acid and basic properties of non-metal oxides. But really, what is an oxide to begin with? So first of all, let's get a definition. So an oxide is a binary compound of oxygen and another element. Now, if we were to sort of think about this in terms of a flow diagram, we could say that the oxides could be metals and non-metals. Okay, and so if we were to think about the metal oxides, then we might have sodium oxide, magnesium oxide. Okay, then if we think of some of the non-metals, then we have carbon dioxide, which is a very familiar one. We have sulfur dioxide, nitric oxide, nitrogen dioxide, and there's some of the main ones that really, and we could also put sulfur trioxide in there as well. As you can see here, we've got all non-metals combined with oxygen. So they're our non-metal oxides. These are our metal oxides. And these are very important when it comes to acid and base qualities of these compounds, because when these non-metals join up with oxygen to make our non-metal oxides, they dissolve in water, they become acidic. And that's a problem for the environment. And we're going to look at that in this video. So let's look at the periodic table, see the distribution of those, and learn how to write some equations. Okay, now that we've drawn a periodic table, let's check out the distribution of these oxides and their acid-base qualities. So down here we have the metals, then we have the semi-metals, and there's a sort of the band of the semi-metals here is a little bit wider when we're talking about the acid-base qualities. So aluminium, for example, is definitely a metal, but it's in this regional, this band, which we're going to be called amphoteric, which just means it has the ability to react as an acid or a base. And so we have this amphoteric region here, right? And so we'll just put A for acid or B for base. They have the ability to react with both. These ones over here, the metallic oxides, are basic. So really, let's just put metallic. And then we have the non-metal oxides, which form acids. All right, so let's draw some equations to illustrate these. So let's look at the metallic oxides first. So here we have magnesium oxide. We dissolve magnesium oxide in water. It's a white powder that you normally probably form in the lab by burning magnesium in the Bunsen burner, combines with oxygen in the air and forms a white powder. Well, if we get that white powder and we mix it with a bit of water, it's a very insoluble compound, but enough of it does dissolve in the water to produce magnesium hydroxide, and of course that then breaks apart or dissociates to produce the hydroxide ion, which is basic. So metal oxides are basic. Then as we move across, their properties change, and so we have this middle region here called the amphoteric. And amphoteric ones, you're not expected to memorize the equations because they can be quite complex, but I'm going to use aluminium here as an example. Okay, so there's our two equations. As you can see, they can be a little bit more complicated than one we've got up here, but here aluminium oxide is acting as an acid. The base here is sodium hydroxide. And what happens here is that we form a salt called sodium aluminate. So since it's reacting with a base here for an acid to produce a salt plus water, then this must be acting in an acid capacity. So an acid by definition is where it can react with a base to produce salt and water for a neutralization reaction. And so here we have down here where the aluminium oxide is reacting as a base, in this case with HCl, to produce the salt, aluminium chloride, and water. So this metal oxide is amphoteric and can react with both acid and base. Then we have the ones up the top here, which are acidic, and we're going to be looking at those in more detail because those are the ones that contribute towards a lot of our environmental problems when it comes to asthma and corrosion and acid rain, etc. But if we just take sulfur dioxide as an example, sulfur dioxide reacts with water to produce sulfurous acid. Okay, and then of course that sulfurous acid can then be converted to sulfuric acid, and we're going to learn that about those equations in a sec. So make sure you get all that down. They can explain the trend as we go from left to right, and let's look in a little bit more detail at the non-metal oxides. All right, and we're back now looking at these three main non-metal oxides. Let's start with carbon dioxide. Carbon dioxide is a gas that we breathe out and is present in the air, and that can react with water to produce carbonic acid. So I've written equilibrium sign there because it does go backwards and forwards, this particular reaction. It's an equilibrium reaction, and we'll look at that a little bit more later when we start looking at buffers, because we can use this hydrogen carbonate and the carbonic acid, I guess you could say ions, and also its molecule, to do buffers. Okay, so the hydrogen carbonate buffer system. So this one here is a very important reaction because the CO2 dissolves in water to produce carbonic acid, and we're going to find out later about how that actually contributes to changing the pH of lakes, and of course that affects the water where the fish live and the oxygen carrying capacity, etc. So that is a big concern, the amount of CO2 in the atmosphere, not only for global warming but also for its effect on acid rain. Let's have a look at the oxides of nitrogen. Now I've put NOx here because there's different types of nitrogen oxides we can form. There's NO, which is nitric oxide, and there's NO2, which is nitrogen dioxide. Very poisonous. So right, these particular oxides here, there's two different types. There's nitrous oxide, nitric oxide. Nitrous oxide is N2O, but anyway, nitric oxide and nitrogen dioxide, right? Now this nitrogen dioxide gas can react with water. Just squeezed it in there. So we have two different types of acids here. We have nitric acid and nitrous acid. So both of these acids are prevalent here, and they're very strong acids. And so these particular gases are of grave concern. And we're going to find out in another video that, of course, these are made in the air by lightning, naturally, and also man-made activities, I guess, by combustion of fuel, combustion of engines. So these are produced around, and the concentrations are high to be of concern when it comes to pollution and making acid rain, etc. Let's have a look at the oxides of sulfur. So we've got sulfur dioxide and sulfur trioxide are the two culprits we're going to be looking at in this particular video, just very quickly before we finish. And if we have sulfur dioxide, that sulfur dioxide can react with water to produce, and I hope you're getting it down there, sulfurous acid. And then we can also have the sulfurous acid reacting with oxygen. I might just do it up here, right? So we have the sulfurous acid reacting with oxygen, right? It's oxidized to sulfuric acid, the good old one that we use in the lab. So sulfur is also of grave concern. It's produced naturally by volcanoes. We'll look at that in a bit more detail in another video. We also produce it by burning coal, and it reacts with water to produce sulfurous and sulfuric acid, so contributing to acid rain. So as you can see, we've got a lot of non-metal oxides here that can react in a variety of ways to produce acidic substances, right? Hydrogen carbonate, nitrous and nitric acid, sulfurous acid and sulfuric acid. So they will change the pH of lakes and waters, etc., to cause a lot of environmental issues as well as human health problems. So that's it for this video. Hope you got all the information. Write down the equations, make some flashcards, get it in your head, and I'll see you in another video. Till then, keep doing your chemistry.